Now, the second goal programming is multiple goal programming. We looked at single goal programming, but oftentimes, as we mentioned before, there are multiple goals that we need to manage. And at the time, how can we find the best approximation, best scenarios? And let's take a look at Harrison Electric Company and continue to see what it can happen. Say there are four goals. Goal one is to produce a profit of $30 if possible during the production period. So the profit level is the first goal. Second goal is to fully utilize the available wiring department hours. That's the second goal. And the third goal is to avoid overtime in the assembly department. So if they are working overtime, that's not a desirable. You have to pay overtime wage, so you want to avoid that. And goal four is to meet a contract requirement to produce at least 7 ceiling fans. So, from the previous case, we did not produce fans at all, but the contract requires them to produce 7 ceiling fans. So can we meet all these four goals, right? And if you have multiple goals, how do you run or use linear programming to reflect this, right? And let's first think about goal one. It's about producing a profit of $30 if possible during the production period. So D1 minus is underachievement. If your profit level is less than 30, it's going to be D1. And D1 plus is overachievement of the profit target. And that's also if your um, profit goes above just $30, then it's going to be your above achievement, overachievement. And the second goal says utilize the available wiring department hours fully. And D2 minus is under utilization. Say, you are supposed to use 30 hours, but you were able to use only 28 hours as a result, 2 hours falling short of. And at the time, D2 minus is going to be 2. And D2 plus is say overtime in the wiring department and you overutilized it. You are supposed to use 30 hours, but now you utilize 33 hours, then 3 hours would be overtime. And goal three is avoid overtime in the assembly department, and in this case, idle time. In other words, you wanted to use you do not want to go overtime for assembly department. For some reason, they are very loaded with so much work and overused, and you want to avoid overtime. And the 3 minus means idle time. You do not overuse them, but less than the capacity you used. D3 plus is overtime. And now D4 and minus and D4 plus is for contract requirement to produce at least 7 ceiling fans. So you are supposed to make 7 fans, but say you produce only 3, then 4 is your D4 minus, and D4 plus would be, say you produced 8, then it's going to be 1. You produce 7, then it's going to be 0. So you have these different deviations, and you're going to use them for multiple goal programming. So then let's set up the problem. So now we are going to minimize the total deviation. The reason is because D1 plus is producing a profit of $30. You don't care about it as much. It's as long as you meet $30 profit level, you are happy. You don't you are not concerned about overachievement of your profit level. So you're not as concerned, so you disregard it. D2 plus is fully utilized available wiring department hours. So in other words, you are not minding overusing the department. So if you are overachieving, that's fine. You don't care about it. So at this moment, you can just disregard it. D3 minus, underachievement of underachievement. So goal three is avoiding overtime. If it is under the time, it's good for you, right? You don't care about it. So at this moment, the concern is overtime, not on, not utilizing it fully. So you can disregard D3 minus. And lastly, D4 plus is meet a contract requirement to produce at least 7 ceiling fans. In this case, producing more than 7 is a good thing, and you don't care about it as much. So you are going to drop these 4 deviations and include only D1 minus, D2 minus, D3 plus, and D4 minus. And you are going to minimize these total deviations in your goal. By doing so, you are just simplifying your problem, and it's much easier for you to interpret your problem. And now also, let's take a look at these constraints are important. 7x1 plus 6x2 plus d1 minus d1 plus. This is profit constraint. It has to be at least $30, and you are concerned about minimizing d1 minus, right? And then 2x1 plus 2x2, this is wiring hours, again, goal 2, and it's 12, and you made it equal rather than less than equal to, and you want to see how you can minimize this D2 minus. And assembly hours constraint, again, you change the sign to 30, and you are concerned about overtime, and you want to minimize this overtime. So D3 minus minus D3 plus is there, the gap is there, but you want to minimize this D3 plus. And lastly, ceiling fans. This is a new constraint, and it says you need to produce at least 7. It's good if it is more than 7, but it's included in this D4 minus minus D4 plus in this gap, and you want to produce uh, uh, um, you want to minimize the under production of this fan. So D4 minus is your concern, and you want to minimize this and make it 7 as much as possible, as close as possible. And there is non-negativity constraints there. And then you can run your goal programming. So I set everything up here, not only X1 and X2. Now I put these 4 goals, and they consist of these gaps between D1 plus minus D1 minus. So I put these variables, these gaps over here, and I enter this coefficient. As we said, D1 minus, D2 minus, D3 plus, and D4 minus is our concern. So I just added 1 over there with to the corresponding variables. And then we have objective function. I use a sum product function, and then I entered these constraints over here, and then ran this Excel solver. I added these constraints here, and the only thing is that I made this as a pure, because this is pure integer programming. I made it all integers, right? So that's the only thing. And then I ran it and found the answer that D1 minus, although so where is D1 minus, right? D1 minus is 0, so they minimized it. And D2 minus was minimized here, 0. And D3 plus was 0. So at least it was not 1 or 2, so it was minimized. So that was really good. And D4 minus, D4 minus was 1. So there was one short So 6 of them were produced, and it was not able to produce 7 of them. If you look at the solution, x1 is 0 and x2 is 6. That was the solution that meets all these 4 goals, and the fourth goal was not met. There was one shortage, and that was the best solution that it could do given these goals. So how great it is that these 4 goals were included, and Excel solver and linear programming found the answer for the business.